Let's talk about density. Density is a ratio. It's a ratio of something's mass to its volume. So we have an equation for density. Density equals the mass of the object divided by its volume, or shortened up, D equals M over V. Density is considered a fundamental property of substances. Different substances have different densities, and the density can actually be used to help identify a substance. When you change the size of an object, its mass changes. Think of a big piece of wood, and you cut it in half, a 2x4 that's 8 feet long. You cut it in half, its mass changes, and its volume changes, but the ratio of them does not change. It still has the same density. Wood has a density that's less than the density of water, and that's why it floats on water. Making the piece of wood smaller, it still floats. Metal has a higher density than water. If you had a 2x4 that was made out of iron, it would sink in water because the density is larger. If you cut it in half, the mass is less, but the density is the same, and it's still going to sink. So we calculate density by taking the mass and dividing by the volume. So here's an example. A sample of liquid has a volume of 22.5 milliliters and a mass of 27.2 grams. Calculate the density. Density has an equation, and so this can't be done just with dimensional analysis. We need to use that equation. So density equals mass divided by volume. And that's something you need to memorize. You need to memorize that equation. So it says calculate the density. So I write down the equation, and then I need to identify what these numbers are. Now, it does tell me volume of and mass of. So it does identify, right? This is the volume. Volume equals 22.5 milliliters. Okay, so I'm going to put this in the denominator for volume. Some problems don't spell it out like that, and then you can look at the unit. Milliliter is a unit of volume. And then it says the mass is 27.2 grams. 27.2 grams. Now I just divide them. 27.2 divided by 22.5. And my calculator gives me a big old long mess. 1.2088 repeating. Just keeps going and going. What happens to those units? Do they cancel out? No, they just sit there. Grams per milliliter. How many significant figures should I report? 3. My mass has 3. My density has 3. I'm doing division, and so my answer should have 3. Here I am measuring in a decimal place that's less than 1. I don't need to worry that I'm going to round this off and change its value. If you're rounding in the tens place or higher, then I recommend putting it in scientific notation before you round it. Here we're going to be fine. 1.2, I'm going to keep that next place, but I look at the digit that I'm dropping. 8 is 5 or greater, and so I'm going to round up. This is 1.21 grams per milliliter. Any questions? So sometimes you have problems like the one we just did where an equation is necessary. You still can have a path. You're given some information where we were given the mass and the volume, and we're asked to find the density, and so we can use this equation to get from one place to another. Here's another one. A customer purchases a platinum ring that has a mass of 9.67 and displaces 0.452 cubic centimeters of water. Is the ring genuine? And for reference, I've provided you with the density of platinum is 21.4 grams per cubic centimeter. So we're asked to find density. So let's set up a path this time. So we're trying to find the density. And they're giving us a mass, right? And a displacement. What the heck is that? Look at this unit. Cubic centimeters. That's a unit of what? Volume. It's a unit of volume. Displacement of water is an easy way to measure the volume of something that's difficult to measure and calculate. So a ring, it would be hard to use a ruler and calculate its volume. But you can put it in a measuring container with some water and see how much the volume rises. And the amount that the volume changes will be equal to the volume of the ring. So we're given mass and volume, and we're asked to find the density. The equation is D equals M over V. So the density is equal to the mass, 9.67 grams, divided by the volume, 0.452 cubic centimeters. 9.67 divided by 0.452. This gives me 21.39380,531. How many sig figs should that have? 3. Our mass has 3, our volume has 3. So let's round that to 3 significant figures. 21.4 grams per cubic centimeter. Is it platinum? Yep. If it was silver or gold or some other metal, the density would be different. Density can also be used as a conversion factor because it relates the mass to the volume. So here's an example for a liquid substance with a density of 1.32 grams per cubic centimeter. What volume should be measured to deliver a mass of 68.4 grams? So I'm going to assume that that sounds like the purple hats and aliens problem to you. What do? Well, we read it all the way through. Let's write down the numbers. So the first number is 1.32. Very important to write down the units. Those are the guide. Now this is a horizontal fraction with a slash, and a lot of times students don't recognize that as a fraction. We do that when we're typing because it's so much easier. Otherwise you have to get out the equation editor, and it's a pain. I've made zillions of these slides. It's a pain. But when you're writing out by hand, it's just as easy to make a vertical fraction. So write it as a vertical fraction. That's 1.32 grams per cubic centimeter. Then you see that as a fraction. The other number, 68.4 grams. What are we trying to find? Volume. It says what volume? So we're trying to find the volume. Density can be used as a conversion factor. This problem can be solved with the equation, but I find a lot of students are not very strong in rearranging equations, and they end up doing it wrong. And so I'd really recommend that you try to learn it as a conversion factor instead, because I really do think it's easier. So the question then is, we have to start with one of these. Which one should we start with? We should start with this one because it's just got a single unit. That can't be a conversion factor, but this one could. So we're going to start with the mass. So we're going to start with grams, and then we're going to make a path to get to volume. Well, we need a unit for volume, right? It didn't ask us for a particular unit. We should probably use this somehow, right? This gives us a relationship between grams and cubic centimeters. So we could go from grams to cubic centimeters. Cubic centimeters is a unit of volume. So that's it then. That equals volume. So I'm going to take 68.4 grams. My path is simple. It's just one arrow. I'm going to have one fraction here, and that equals something. Grams to cubic centimeters. So down here, grams to cubic centimeters. I want this gram to go away, so I'm going to divide by grams because I want those to cancel out. With my units in place, now I can go looking for numbers that relate cubic centimeters and grams. Over here, I have 1.32 grams per cubic centimeter. 1.32 is with grams. So I'm going to write the 1.32 in the denominator. There's no number here. It would be a 1. Because when you multiply or divide by 1, it doesn't change anything. So a lot of times we just leave it off. Because for this liquid, 1 cubic centimeter weighs 1.32 grams. This is true for this liquid. So I take my calculator, I've got 68.4, and I multiply by 1, I divide by 1.32, and my calculator says 51.81818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181818181n:::::::::::::::::::::::::::::::::::::::::::::::::::::::::::: And just keeps going. The unit would be cubic centimeter. And then I always ask myself, how many significant figures? 3. The mass had 3. The density has 3. I'm going to round this to 3. We've been working on significant figures on the worksheet in lab this week, and I know a lot of students struggle with that. And on that first test, there will be questions specifically about significant figures. So I want you to give it your best shot and learn it. But you can pass this class with only a shaky understanding of significant figures. I want you to try. But if it's just a big old mystery to you, that's not going to be a huge problem. Dimensional analysis is essential to learn. Okay, so what we're doing here with the units, this is super, super important. It's really hard to pass if you don't get this. So just a shortcut again for sig figs in these problems. Like I said last week, a lot of times, however many significant figures are in the number you're starting with, that's how many you'll end up with. And you'll see that happens over and over again. So if you really hate significant figures, use that shortcut and you'll be okay. Any questions? Yes. Yes, you can use D equals M over V and flip it around. My experience when people flip it around is they often do it wrong. So if you're good with algebra, you go right ahead and do that. That's fine. Here's a table in your textbook that lists densities of some common substances. Pointer's having a problem. The unit up here, grams per cubic centimeter. You do not need to memorize this list. The density of water is useful to remember. It's 1. But the rest of them, if you need it, look it up. If you need it on an exam, it will be provided somewhere. Okay, a drop of acetone, which is the useful ingredient in nail polish remover, has a mass of 35 milligrams and a density of 0.788 grams per cubic centimeter. What is its volume in cubic centimeters? Okay, so let's write our numbers down. We've got 35 milligrams, and we've got 0.788 grams. Write this as a vertical fraction. grams per cubic centimeter. And then we ask ourselves, what are we trying to find? Volume in cubic centimeters. So for my path, I want to end up with cubic centimeters. Then I have to figure out where am I starting. I have two choices. I could be starting with 35 milligrams, or I could be starting with 0.788 grams per cubic centimeter. This one cannot be used as a conversion factor, so this is probably where I'm going to start. So I'm starting with milligrams. Can I go from milligrams to cubic centimeters in one step? Do I have a relationship for that? Not quite. I've got this density, but this is grams to cubic centimeters. I can use that to go from grams to cubic centimeters. How do I get from milligrams to grams? Can I do that in one step? Yeah. Okay, so this ends up being a multi-step problem. So 35 milligrams. I've got two fractions because there are two arrows. Milligrams to grams to cubic centimeters. I divide by milligrams because I want that unit to go away. I divide by grams because I want that unit to go away. What I want left is cubic centimeters. After the units are okay, then I go looking for numbers. Let's look at this guy. This is 0.788 grams per cubic centimeter. Well, over here I have grams and cubic centimeters in the same fraction. I have to keep the numbers with their units, so the 0.788 stays with grams. You don't have to figure out, should I multiply or divide by the density? The units will do that for you, and that would be 1 cubic centimeter. Milligrams and grams. This is a conversion factor using metric prefixes. What does milli mean? 10 to the minus 3, 10 to the negative 3. So milli stands for 10 to the minus 3. So milligram is 10 to the minus 3rd grams. 1 milligram is 1 times 10 to the minus 3rd gram. So I've got 1 times 10 to the minus 3rd and 1. Following the pattern that I'm teaching you with the metric prefixes, you're never going to have the 10 to the something with the prefix. Okay? There are other ways to do it, and if you're good at that, that's fine, but I don't want to confuse people. So when I do this on my calculator, I've got 35 times, I put this 1 in front of it because now this is scientific notation, and that's easier to do on the calculator. This is 1 EE negative 3. So I've got, my keystrokes are 35 times 1 EE negative 3 divided by 0.788 equals. And my calculator says 0.0441624. How many significant figures? 3 is a great guess. That's very close. 35 milligrams. How many significant figures? Just 2. That looks like it could be an exact number, right? Because it's a whole number. But you can't count milligrams. You can measure them, but you can't count them. They are not objects. So 2 significant figures. The leading zeros are not significant figures, so I'm going to keep the first 4 and the second 4. So our answer is 0.044, and the unit is cubic centimeters. Any questions? A pure gold bar displaces 0.82 liters of water. What is its mass in kilograms? Here's the density of gold. Well, let's take these numbers and write them down. 0.82 liters, and I've got 19.3 grams, that's not gram, grams per cubic centimeter. What do I want to find? Mass in kilograms. I've got to start with one of these. What am I going to start with? Liters. I'm going to start with liters, and I have to figure out how to get from liters to kilograms. Kilograms and liters are not in this density at all. But gram is related to kilogram just by a prefix, right? So we could go from grams to kilograms. That wouldn't be a problem. All we have to do is remember what kilo means. This density gives us the relationship between grams and cubic centimeters. I'm working backwards on this one, huh? Cubic centimeters. Liters and cubic centimeters. Milliliters. So here's an often overlooked relationship. 1 milliliter is the same as 1 cubic centimeter. Exactly the same. So going from milliliters to cubic centimeters is very easy. Liters to milliliter is just another prefix thing. So this one's a little more involved, right? But once we've got the path, we just follow the pattern and it'll be fine. I'm going to start a little lower in case I run out of room. So 0.82 liters. I have 3 arrows. I need 3 fractions. Liters. How many arrows are there? There's 4 arrows. I can't count. I had to take a kid to the eye doctor this morning and get his glasses fixed. And I said, "Do you have any more babies lately?" I'm like, "No, I cannot remember the names of the ones I already have." There will be no more babies, hopefully. Liters to milliliters. We're just trying to keep it together here. To cubic centimeters, to grams, to kilograms. I'm just writing these same units. Liters, milliliters, cubic centimeters, grams, kilograms. Liters, milliliters, cubic centimeters, grams, kilograms. Copying them down. I take the unit of the first term and I put it in the denominator of the second one so that that unit cancels out. So I want those to go away, and then I'm going to get rid of milliliters, and so that goes away. And then I put cubic centimeters down here, and those cancel out. And I put grams down here, and those cancel out. And then I need to put numbers in. You can put the numbers in. You can do the last term first or the middle term first, whichever one just jumps out at you and says, "Oh, hey, I'm easy." This one looks pretty easy. So right here, cubic centimeters and milliliters, 1 cubic centimeter to 1 milliliter. That one's nice. Grams and cubic centimeters, that comes from the density that was given in the problem. The 19.3 goes with grams. So this time, the 19.3 is in the numerator and 1 cubic centimeter in the denominator. We've already done milli today, so let's do this one first. Milli means 10 to the minus 3. I've got milli on top, I want to put what it means down here. 1 milliliter is 1 times 10 to the minus third liter. And then over at the other end, I've got kilo. Kilo means 10 to the third plus 3. I've got kilo on top. I'm going to put what it means on the bottom. 1 kilogram is equal to 1 times 10 to the third grams. And now I use my calculator. 0.82, I'm going to divide by 1 EE, negative 3, times 1 divided by 1, times 19.3, divided by 1 EE, 3 equals. And now I get 15.826. And I have to ask myself, how many significant figures? 3 is a great guess. It's actually 2 again. 0.82. The 0 is a leading 0, doesn't count. So I have 2 significant figures here. This is exact. This is exact. This is not exact, but it has 3 significant figures. And this is exact. So I need to round this off to 2 significant figures. So I'm going to say 16 kilograms. Any questions? That's the last one. Okay, this will be fun. You really doubt that? That's fine. It'll be fun for me. How's that? I have different ideas of what's fun. Okay, a gold-colored pebble is found in a stream. You might get excited. Hey, this might be gold. Its mass is 23.2 milligrams. Its volume is 1.20 cubic millimeters. What is its density in grams per cubic centimeter? Is it gold? The way we're going to figure out if it's gold is we're going to compare the density of the pebble to the density of gold. If they're the same, it's gold. If they're different, it's not gold, it's something else. So I've got some numbers here. Let's write them down. 23.2 milligrams. 1.20 cubic millimeters. And 19.3 grams per cubic centimeter. So those are the things that were given, and what do they ask us to find? Density. Okay, so we're supposed to find the density. You can use density as a conversion factor, and I encourage you to do that. When you calculate the density, you have to use the equation. So since we're finding the density, we're going to need to use density equals mass over volume. So what's the mass? Which of these is the mass? Milligrams. So 23.2 milligrams. And the volume is 1.20 cubic millimeters. So the density equals 23.2 divided by 1.2, 19.33 repeating. What are the units? Milligrams per cubic millimeter. We found the density. Are we going to get this right on a test question? No, because it says grams per cubic centimeter, and we've got milligrams per cubic millimeter. Dang. There's going to be unit conversions in here after all. There are different ways to approach this, okay? You could say, well, I'm going to go back and change these so that this is in grams and this is in cubic centimeters, and then I'm going to stick them in the density equation. That's probably the most straightforward, least confusing way. It's also possible, though, to take this and apply conversion factors and convert the milligrams to grams and convert the cubic millimeters to cubic centimeters. I'll save that for lab. So let's fix these guys up, okay? If we want to convert 23.2 milligrams to grams, anytime you have two metric units, with one has a prefix, one has no prefix, you can always do that in one step. Grams to milligrams or kilograms to grams, anything like that. So I'm going to convert milligrams to grams. That means I need to divide by grams. Milligrams. And then I ask myself, what does milli mean? Milli means 10 to the minus 3. So I'm going to put that on the other side. Milli is a nickname, if you will, an abbreviation for 10 to the minus 3. Don't use them together. So this is 1 times 10 to the minus 3, and that's 1. So then my calculator, I've got 23.2 times 1 EE minus 3. And that's going to be 0.0232 grams. And then I need to convert, this is getting to be a mess. Let's pull this trick. I need a little space, so I'm just going to make some. We need to convert the volume. I've got 1.20 cubic millimeters. I need that to be cubic centimeters. I'm going to pretend the 3 isn't there at first. Both of these have prefixes. We need to be careful and think about this a little bit more. So cubic millimeters, we're trying to get to cubic centimeters. Both of these have prefixes. 2 prefixes, I recommend 2 steps. It can be done other ways, but I wouldn't even do it. So go from the millimeters to meters and then to the centimeters. So go from the unit with a prefix to the unit without a prefix, and then from the unit without the prefix to the unit with the other prefix. 1.20 cubic millimeters. I'm going to do this in 2 steps. At first, I'm going to ignore the cube, and I want millimeters down here, and I want meters down there. I'm going to get the numbers in, and then I'm going to bring the cube back. Milli means 10 to the minus 3. So 1 times 10 to the minus 3 meters is the same as 1 millimeter. Centi means what? 10 to the minus 2. So I've got centi on top. I'm going to put what it means on the other side of the line. 1 centimeter is 1 times 10 to the minus 2 meters. Because these are cubed, I need to cube the whole thing. So I've got 1.2 times 1 EE negative 3 cubed divided by 1 EE negative 2 cubed. And I end up with 0.0012. How many significant figures would that have? 3. The calculator just shows it with 2, but I started out with 3. These are metric conversions. Those are exact. That was a significant zero, a significant digit, and so I need to bring it along with me. So there's my cubic centimeters. So now I can put this in 0.0232 grams and dividing by 0.00120 cubic centimeters. I get 19.3. How many sig figs should that have? 3. 19.3 grams per cubic centimeter. It came out the same as this one. It's okay. Milligram is a smaller unit, and millimeters cubed is a smaller unit than these units. And the factor by which they are different is the same, and so the density ends up being the same in both units. Is the pebble gold? Yes, it is.